The section 1.2 of the book is focused on the idea of domain and range, but the real reason that we talk about it in any detail is so that we can introduce some notation that will allow us to answer other questions as well as this kind of question. And this notation comes up, of course, not only in this class, but in your calculus class you'll take eventually. So the question here about domain and range requires that we remember that the domain means all the possible inputs, all the legitimate inputs into a function, and the range is our term for what are the outputs, what's the span of outputs that come out of the function. The function that you see written down here is not given as an algebra formula, but rather we just give a graph, and that's so that we can really focus on that connection between graphs where the first coordinate of a graph is the input and the second coordinate of a graph is the output. So what we're really trying to see here is what's the span of x coordinates and what's the span of y coordinates that we ever see on this graph. So the way we would do that for a graph is I want to label my extreme values. So like the point up there is 3, 8, and that is the biggest input you'll ever see, and that's the biggest output you'll ever see. So in other words, that's the largest x coordinate and the largest y coordinate that we'll ever see. So that tells us one end of our range. Another extreme value is down here. The point down here is 0, -1, and we can see that there are no second coordinates, there are no outputs that are further down than that. So our outputs are definitely numbers that are between -1, I'll use y to represent my outputs, but between -1 and 8. Any number between -1 and 8, if I were to follow along the graph, every point on the graph has a second coordinate that's between -1 and 8. And so it's easy to see because it's just the highest point and the lowest point on the graph. The inputs have a slightly different story here, and it's because of this weird notation that I've used on the left side. So the coordinates of that dot are -2, 3. So that's simple enough. But the white dot there is supposed to look like it's an unfilled circle. So over on 3, 8, the circle looks like it's filled in, and on the left side it looks like an unfilled circle. That is supposed to represent the fact that the point -2, 3 is not actually on the graph. It's all the points leading right up to that, but not the point -2, 3. So in other words, you could have an input of -1.999, that would be perfectly fine, but you can't have an input of -2. So the way we would convey that, the largest output we see is 3 from the rightmost point way over there. So that's not the 3 in the open point, that's the other 3. So over here, the biggest input value I can use is 3. The smallest input value that I see on here is -2, but -2 is not actually allowed. So I can distinguish between those by using the less than symbol rather than the less than or equal to symbol. So x can be anything that's bigger than -2, but it can't actually be -2. And so that's how I would answer that question. The possible inputs, as we call that the domain, and the possible outputs, we call that the range. So when you have a graph in front of you, it's actually a fairly easy question. It's just a matter of marking and reading off coordinates of the extreme points on your graph and then writing it down in the correct notation. So let's talk a little bit about notation, because this is just one question, the first question, where the answer to the question is a span of x values or a span of y values. But those kind of questions, the questions that have those kind of answers come up quite a bit. So we actually have some special notation for those. All right, so when I have an expression where I'm trying to describe all the numbers between two things, you've seen how we can do that with inequalities. So in the first sentence here, I was describing all the x's so that x is between 2 and 5, but x is not allowed to be 2, but it could be allowed to be 5. There is something called set builder notation where you just write exactly that, sort of in a mathy way with the little set brackets and that vertical bar there. We would read that as such that, so you would say all x such that 2 is less than x is less than or equal to 5. You can just read off that in words, and that does convey what you're trying to say, but it's a little lengthy. So we can shorten that using what's called interval notation, where we just only put in the essentials into that notation. So obviously the 2 and 5 matter because you're saying it's all the numbers between 2 and 5, and I want to have some way of conveying that 5 could be included, but 2 should not be included. And I do that by distinguishing with a rounded paren versus a closed brace. So the closed brace means that you're including the possibility of that value. The open paren means that you're saying you can't actually get to that value. So everything between 2 and 5, where 2 is not allowed but 5 is, would be represented with the interval that you see there. It's not you could have an interval where both sides are the closed, the square bracket. You could have a brace. You could have both sides with the open paren. There's no, I mean, it just depends on what you're trying to describe. The more visual way to describe that is with a number line. You can see here, the way we would describe that is by basically sucking the essence out of the other graph. And so the open circle at 2 is indicating that I'm not going to ever really get to 2. The closed circle, shaded in circle at 5, is indicating that it's okay to get to 5. And then I'm shading the stuff in between, and you'll see me kind of shading badly like that, shading in between, but I'm trying to draw a picture where I'm shading all of the allowable values. So that's 3 different ways of writing the same thing. And because the middle one, the interval notation, is the most compact, then that's the one that you see a lot in math classes. So here are some problems to practice. Your best bet is to pause the video and try writing these things down. We're going to try to write everything in all 3 ways. So I'll draw number lines for these, but I'm just going to count to 3 and then just put them on here. So you can pause if you want to do it first. So here are the pictures for the first 2 and the intervals for the second 2. The one thing in the last one is the word, the second bullet. So this one and this one, right? They use this little U thing. It's called union. And that's our way of patching together when there's more than one span that we want to include, but they're not connected to each other. We can just describe them each separately and put the little U in between them. And we see that happening on the bottom one as well. The other thing that's happening in the bottom one is here we're seeing x greater than 8, which doesn't look like a between statement. So we have to interpret x greater than 8 as just being x is between 8 and infinity. That's the way we would want to describe that. And that way we can use the same kind of notation. So the intervals are always describing numbers between the first thing and the second thing. And if you want to go in one direction or the other, then your first thing could be minus infinity or your second thing could be positive infinity. And that's the way we can describe an unbounded interval. Anyway, we'll see that when we look at some domains in a second. So here are the way this comes up in domain questions. We know that the square root function, for example, in this first example, g of x, you can't apply the square root function to negative numbers. And so if you're not sure, you can just try out some things. So, g of 3 would be the square root of 3 minus 3. And that's the square root of 0, and that's fine. If you're not sure, use a calculator for the square root of 0, and you'll see that it's cool. On the other hand, if you try to put 0 in, for example, for x, that would be the square root of 0 minus 3, or the square root of negative 3, and that's going to cause an error. So that's going to be bad. So we can see that 3 is okay as an input for this function, but 0 isn't. The first example of g of 3 kind of tells us what's happening there, because putting 3 in for x makes that say the square root of 0. That's kind of the extreme value. The 0 is the smallest number you can take a square root of, and so 3 is the smallest number that you can put in here. So that kind of indicates to us that this is going to be the right choice here. But if you're not sure, you can just put in some other values. But 3 is definitely legitimate. We just did it and got an answer. So the fact that 3 works means this is not the answer. We know we can't put 0 in, so that's not the answer. And then the d interval says everything between minus 3 and infinity, which would include 0, putting a 0 in for x, which we already said we can't do. So by just putting in some values, you can see which one of these is correct. When we have a function with a fraction in it, like the second example, 1 over x plus 1, the only problem with that possibly is if that said divide by 0. And the only way that could possibly say divide by 0 is if the denominator there were 0. And the denominator of this fraction is 0 only when x is negative 1. So we can do that analysis, and we can see that x equals negative 1 is the only bad value. So in other words, that's the only number that's not included in the domain. It's the only number that's going to cause an error. So one of the challenges is that's a very easy thing to say, that you can use any number except negative 1. The challenge is writing that in interval notation. And so it seems kind of dumb, but if you are really forced to write this in interval notation, it'll be like this. What D is saying is all numbers between minus infinity and minus 1, not including minus 1, or all the numbers between minus 1 and infinity, not including minus 1. So those two intervals together account for every single number except negative 1. So when only one number is bad, then this is going to be the way we can write that with interval notation. It feels dumb. Nobody really would do that. They would just say every number but negative 1. But what happens is, like on the online homework, it's set up so that it'll ask you a question and it wants the answer to be in interval notation. So if this were the question, then that is the right way of saying it in interval notation. But it's not a very convenient way of saying it in regular English. Okay, so this slide sort of tells you a process for the different kinds of functions we have, and this is what we said on the first day, just more abstractly. When you have a function that doesn't have any dividing by x's or square roots or anything, then your domain is going to be all the real numbers. Like, there's no problem. If you're not dividing by x, you're not taking the square roots of x, then there's not going to be any issue with anything. So you can put any number in. If you have a fraction looking thing, then the only thing that can cause a problem is with the denominator being 0. And so you're going to figure out your domain by just figuring out where the denominator is 0 and then just saying all numbers except for that. And then the one that will seem a little more challenging is when you have the square root. When you take the square root of some stuff, it's totally fine as long as the stuff is not negative. And so that's what you're going to try to figure out is, what does it mean for that stuff to be not negative? And then we can figure out the statement of the domain from there. So for example, this first function is a rational function. It's got stuff with x's in the denominator. And so it's possible that we're dividing by 0, but it's easy to figure out when that would happen. I would take the denominator that I see and figure out where that denominator is equal to 0. So in this case, that'll be negative 1/2. And so all numbers except 1/2 is going to be my domain. And the way I would say that is all numbers between minus infinity and 1/2, or all numbers between 1/2 and infinity. And so that only leaves out the number negative 1/2. That only leaves out the number negative 1/2, which is what I want to do. Number 2, for g of x, we have the square root stuff, and so I need to know when that stuff under the square root sign is non-negative. So the first thing I do is figure out when it's equal to 0, because that'll be my extreme value. So if I solve that equation, it will tell me that the stuff under the square root sign is 0 when x is 2/3. So that's right here, and so that should be okay as a domain element. If you check, g of 2/3 is going to say the square root of 0, and we know the square root of 0 is 0. And so that's fine. That's good. The question is, that'll be the extreme, but should I be shading to the right or shading to the left? The easiest way to tell is by just picking another number, like here it suggests 0, for example. So just C is 0 in the domain, and so that would mean just figuring out whether I get an error message or not when I do this. So just try plugging 0 in. That says square root of negative 2, so that's bad, right? That's no good. Oh, I want a sad face, hang on. There we go. So that's bad. So 0 should not be in the domain, and that indicates to me that this should be shaded in the other direction. And if you're not sure, try another number, right? Try like g of 2 and make sure that's okay, like that, and you'll find out that it is. So g of 2 will be okay. So you can just feel your way through this. The relevant thing is, in each case, we need to know where we have the extreme value, which means we're trying to figure out where something is equal to 0.